Let me put you inside a story you can feel. You built an app. It started small, one database sitting on one server, quietly doing its job. Life was good. You would ask it for a user. It would answer in a blink. You would save a new order. Done. That one little database handled everything. Then your app got popular, and popular is wonderful until it isn't. The data kept piling up. 1,000 users become a million rows become a billion, and one day your database server starts groaning. The disk is nearly full. Queries that used to be instant now drag. Every write, every new sign up, every order, every like has to go through this one machine, and that one machine is starting to sweat. So you do the obvious thing. You buy a bigger server, more memory, more disk, a faster processor. This is called scaling vertically, making one box stronger, and it works for a while. The app speed up again, you breathe out. But then you grow again and you go to buy an even bigger box and you hit a wall. There is no bigger box. The biggest machine money can buy still isn't enough. And even before that, the prices get insane. Doubling the power can cost you 10 times the money. You can't just keep buying your way up forever. Okay, you think I will add read replicas. Good instinct. A read replica is a copy of your database that handles reads. So the main one isn't drowning. And that helps, but only with reading. Replicas don't help you write faster because every write still has to go to the main database, and replicas don't help with the storage either. Each replica is a full copy. So if your data doesn't fit on one machine, copying it 10 times doesn't fix anything. It just gives you 10 machines that are all too small. So here you are, too much data to fit on one machine, too many writes for one server to keep up with. A bigger box isn't possible. Replicas don't solve it. You are stuck. That's the wall, and there is only one real way through it. How the idea of sharding solves it. Picture an old office with one filing cabinet. Every customer file in the whole company lives in that one cabinet. For years, fine, but the business grew and now that cabinet is jammed shut. You physically cannot stuff another folder in, and every morning the whole staff crowds around that one cabinet trying to pull files at the same time. It's chaos. You can't make the bigger cabinet. It already fills the corner of the room. So someone asks the simple obvious question, why are we keeping everything in one cabinet? Why don't we just get more cabinets and split the files across them by the rule? And that's the whole idea. You bring in several cabinets. You make a rule. Customer whose last name starts with A through M go in a cabinet 1. N through Z go in cabinet 2. Now each cabinet hold only part of the files. Each one has room to grow, and when someone needs a file, they don't crowd one cabinet. They walk to the right one based on names. That's sharding. In one sentence, sharding means taking one giant database and splitting it into many smaller databases, where each one holds only a slice of the data and a rule decides which slice goes where. A library does the same thing. When one branch can't hold all the books, you open more branches and split the collection across them. No single building has to hold everything. That's sharding too. Instead of one machine doing all the work for all the data, you have many machines, each responsible for a piece. Add more data, add another cabinet. This is scaling out instead of up. And unlike the bigger box approach, it doesn't hit a wall. Now what exactly is sharding? Let's make this concrete and name the few words you actually need. Sharding is a form of what's called horizontal partitioning. That sounds fancy, but it just means you are splitting your data by rows. Imagine your big table of billions users. Sharding takes that table and says these rows live over here, those rows live over there. Each of those pieces is called a shard. And here is the important part. A shard is not a half database or a fragment. Each shard is a complete, fully working database on its own server. It just happened to hold only a subset of rows. Cabinet 1 is a real, complete cabinet. It simply doesn't contain all the file. So one big database becomes, say, 4 shards. Each shard is an independent database on its own machine, holding roughly a quarter of data and handling a quarter of load. Now, the one thing that makes all of this work or fall apart is the shard key. The shard key is a piece of information you use to decide which shard a row belongs to. In the filing cabinet, the shard key was the customer's last name. In the real system, it might be the user ID, the country, or the date. The shard key is the heart of sharding. Choose it well and everything flows smoothly. Choose it badly and you will be in pain for years. We will come back to why. Now, why use it? 3 real wins, and each one solves a problem that nothing else could. It breaks the storage ceiling. This is the big one. If your data is too big to fit on one machine, sharding is the answer that actually works. 10 machines holding a tenth each can store 10 times what one machine ever could. There is no single box to outgrow. Second, it spread out the writes. Remember, read replicas couldn't help you write faster. Every write hit the one main database. With sharding, writes get split too. Write for user A through M go to one shard. N through Z goes to another. Each shard only handles its own share. So no single server is the bottleneck anymore. It spreads out the load in general. More machine means more total memory, more total processing power, more connections. The traffic that was crushing one server now gets divided across many. Each one breathes easy. Storage, writes and load all split across machine that you can keep adding. That's the payoff sharding gives you, that vertical scaling and replicas simply cannot. Now, how to use it? It's internal working. Let's walk through what actually happens slowly like a replay. A request comes in. Give me user number 7000's profile. Somewhere there is a routing layer. This can be a separate piece of software in front of your database or just a logic inside your application. Its whole job is to look at the shard key and figure out which shard holds the answer. It checks the rule, decides user 7000 lives on shard 3 and sends the query straight there. Shard 3 answers done. The other shard never even hear about it. That's the basic loop. Look at the shard key. Pick the right shard, send the query there. Now the only real question is, what rule do we use to split the data? There are 3 beginner friendly ways and you should know all 3. First is range-based sharding. You split by range of the key. Last name A through M on shard 1, N through Z on another, or user ID 1 to million here, 1 to 2 million there, or by date, January's data on shard 1, February's on next. This is a simple to understand and great for range queries. If you ask, give me everyone from A to F, they are all sitting together on one shard. The catch? The data might not spread evenly. Imagine you shard by sign up date and everyone sign up this month. All that traffic slams the one shard holding this month while the other sits idle. That's called hotspot. One shard burning while the rest are bored. Second way is hash-based sharding. Instead of using the key directly, you run it through hash function. A hash function is just a little math machine. You feed it the key and it split out the number that looks random, but it always the same for the same input. You use that number to pick the shard because the output is spread out. Your data lands evenly across all shards. No hotspot from clustering. That's the big win. Beautiful, even distribution. But you pay for it. Range queries become painful because related rows get scattered everywhere. Everyone from A to F is now sprinkled across every shard. So you have to ask all of them, and there is a second sting. If you add or remove a shard, the math changes and suddenly huge amount of data have to be reshuffled to new homes. There is a clever fix for that reshuffling problem called consistent hashing. But that's an intermediate course topic, so just tuck the name away for now. Third way is geographic or location based sharding. You split by region. European users on shard sitting in Europe. American users on a shard in the United States. The win here are real. Users talk to a server that's physically close to them. so things feel faster, lower latency, and it helps with data residency laws, where some countries legally require their citizens' data to be sorted inside the country. The catch is familiar. If one region has a way more users than the others, that shard gets overloaded while the rest stay quite uneven again. So under the hood, it always the same shape. A routing layer reads the shard key and points the query at the right shard. The only thing that changes is the rule you choose to split by. Now, trade-offs of using it. Sharding feels powerful, and it is, but I need to be honest with you. Sharding is hard. It should be last resort, not the first move. Here is the real cost. Queries across shard becomes painful. When all your data lived in one place, asking how many users do I have in total was one easy query. Now the data is spread across 4 machines. To answer, you have to ask every shard, then stitch the pieces together yourself. Anything that needs to look across the whole data sets just got slow and complicated. The second point is joins get hard. In normal database, joining related data, say users and their orders, is simple. But if a user lives on shard 1 and their orders happen to live on shard 3, the database can't just join them. Join across shards are slow and clumsy, and sometimes you have to do the work in your application instead. Third is transaction across shards are tough. Suppose you need to move money from one account to another and the two account lives on a different shard. Making sure both halves succeed and both fail together, that's hard when they are on separate machine. The clean guarantees you got from a single database get much weaker here. Rebalancing is scary. One shard fills up or gets too hot. Now you need to move data around to even things out, often while the system is live and serving real users. This is one of the most nerve-wracking operations in all the backend engineering. Next point is you lose simplicity. One database is easy to reason about, backup and fix. Many shard plus a routing layer is a more complex machine with more parts that can break. So the trade-off is clear. You give up simplicity and easy query in exchange for the ability to scale past what one machine could ever do. When you truly need it, and it's worth it. When you don't, it's a self-inflicted wound. Now when to use it? Reach for sharding when your data genuinely doesn't fit on one machine anymore. This is the cleanest reason. When storage is the wall, sharding is the real answer. Your writes have outgrown a single server. You have already added read replicas. Reads are fine, but the writes are still crushing your one main database. Sharding splits the write load. You have already tried the easier thing. You have added caching, you have added read replicas, you have scaled the box up as far as it goes, and you are still hitting limits. Now sharding earns its place here. Your data splits naturally. If your app is built around clear units, separate customers, separate regions that line up neatly with a shard key, sharding fits cleanly. Now when not to use it? Hold off on sharding when you haven't tried the simpler option yet. Caching, read replicas and the bigger server are far easier and solve most problems. Don't jump to sharding while these are still on the table. Your data still fits comfortably on one machine. If one box can hold your data and handle your traffic, sharding only adds pain for no gain. You do a lot of cross-cutting queries and join. If your app constantly need to look across all your data at once, sharding will fight you every single day. You are not sure of a good shard key yet. If you can't confidently pick a key that spread data evenly or won't need to change later, you are not ready. A bad shard key is worse than no sharding. The golden rule is shard only when one machine truly can't cope and only after the easier tools have run out. Now let's look at the common mistakes. A few traps that catch almost every beginner. Sharding too early. This is the big one. People hear sharding and reach for it like a trophy long before they need it, but sharding multiplies your complexity. Try caching first, try read replicas, try bigger server. Most apps never need sharding at all. Only shard when the simpler tools are genuinely exhausted. Picking a bad shard key. Choose a key that clumps the data together and you create a hotspot. One shard on fire while other nap. Choose a key tied to something that grows in order like a timestamp and all the new traffic piles onto the newest shard. A good shard key spreads both data and load evenly across every shard. Picking a key you later have to change. This is a nightmare scenario. The shard key decides where every row lives. If you realize months later that you choose a wrong, fixing it means moving enormous amount of data while the system is running. Think hard about the shard key before you commit, because changing it later is brutal. Forgetting about cross shard operations. Beginner shards the data and then act shocked when total joins and transaction across shards suddenly become hard. Before you split, ask yourself, which of my queries need to touch more than one shard and how will I handle them? Some of the interview questions on this concept are: what is sharding and why do we use it? What's the difference between vertical scaling, read replicas and sharding? What is shard key and why does it matter so much? Explain range-based versus hash-based sharding. What is a hotspot and how do you avoid one? Why is sharding considered a last resort? What gets harder once you shard? Here are 3 things to walk away with. Sharding means splitting one giant database into many smaller ones called shard. A shard key and routing layer make it work. Sharding is powerful, but it's a last resort.